NASA has a history of launching some of the most successful crafts in the history of space exploration, being the first to land humans on the moon, and with the current plans to explore the Milky Way to the depths, they certainly have made the most significant breakthroughs ever. Recently, one of their oldest spacecrafts, the Voyager, had a pretty exciting encounter, billions of miles away from the Earth. It reported a strange humming sound, which ideally would not be possible because space is filled with a vacuum. NASA launched Voyager 1 on September 5, 1977, as part of the Voyager mission to research the outer solar system and interstellar space beyond the realms of the Sun. Voyager 1 was launched 16 days after its twin, Voyager 2, and has been communicating with Deep Space Network for over 44 years. It still receives standard commands and transmits data to Earth via the Deep Space Network. By crossing the heliosphere, or the outermost atmosphere of the Sun, it is currently the farthest artificial object from Earth at a distance of 14.45 billion miles. The spacecraft's extended mission, like that of its sister vessel Voyager 2, is to locate and explore the regions and boundaries of the outer heliosphere, as well as begin exploring the interstellar medium. On August 25, 2012, Voyager 1 became the first spacecraft to breach this part of our solar system and enter interstellar space. Mission planners took advantage of a rare alignment of the planets that occurs once every 175 years to accomplish these achievements. This alignment allowed the spacecraft to slingshot back and forth using natural gravity forces. The craft was transferred to an interstellar phase on their route out of the solar system after the main missions finished in 1989, with Voyager 2's encounter with Neptune. Voyager 1 reached interstellar space in 2012, a location where the Sun's impact is no longer felt. Physicists have long predicted the presence of unstable plasma throughout the universe. Plasma is created when a gas is heated to such a high temperature that its atoms and molecules are ripped apart into their constituent ions and electrons. Plasma is formed with distinct characteristics in the region of space closest to us, our solar neighborhood, due to heat and radiation from the Sun. The Sun's heat and radiation transforms rogue gas and solid matter molecules into plasma, filling space. The plasma of the interstellar medium was supposed to take on different characteristics outside of this bubble, known as the heliosphere. The Voyager 1 spacecraft demonstrated this perfectly. Researchers could only gather hints about interstellar plasma from studies with distant telescopes before Voyager 1. Voyager 1 began receiving direct signals from the plasma after passing beyond the heliopause, separating the Sun's neighborhood from interstellar space. These signals arrived in the form of powerful electrical discharge bursts on occasion. The plasma wave system on Voyager 1, one of the craft's few remaining instruments, did the job of identifying the bursts. The plasma wave system functioned much like a voltage meter found on a household electric socket. The instrument's occasional torrents of plasma were powerful, like weighing 100 pounds on a scale with the smallest measurement of 1 pound. Scientists subsequently pieced together a picture of these signals created by shock waves that occasionally erupt from the Sun, causing the plasma in the spacecraft's proximity to shake, causing oscillations in the spacecraft's electric field. Researchers identified a small but smooth signal lying in the background of the data when evaluating the overall electrical measurements collected from 2017 to 2020. Though it has the same core electrical nature as the storm, this signal is more like a steady pitter-patter than a storm's periodic rush. Dr. Stella Koch-Acker of Cornell University discovered a weak yet constantly flickering signal from the Voyager 1 craft in May 2021. She was stunned by this and believed that this was all by fluke or was probably a glitch in the communication systems of the craft. Stella said in an interview, "I was literally just kind of staring at a plot and I thought I saw something faint. And I was like, am I starting to see things?" In a recent investigation, Koch-Acker and colleagues described a new signal from the plasma wave system instrument aboard the craft. They utilized these findings to calculate a new density for the interstellar medium, a thinly scattered mixture of molecules, atoms, and ionized gas, or plasma, filling the space between stars. The findings, published in the journal Nature Astrophysics on Monday, are the first continuous measurements of plasma density that prove the existence of gases in the interstellar medium, which has previously only been known in isolated areas. Nothing concrete can be proved from these signals, but this has given NASA the kickstart they need to dig deeper into the research to find out where this has come from, and that is precisely what they are doing. A stronger team has been established to monitor every movement of the Voyager, which is currently speeding out into the solar system at a phenomenal speed of 38,000 miles per hour. To demonstrate how fast this is, let's say that if a person was sitting at this speed inside the Voyager, and assuming that the craft stopped for even a split second, the person's body would disintegrate head to toe within that very second due to the inertia. Prior methods of determining plasma density relied on picking up solid and irregular signal bursts from Voyager 1, which seemed to happen once a year or so. The new signal, which appeared in data from 2017 to 2020, is only a few times stronger than the instrument's sensitivity, making it barely noticeable. The plasma wave system on Voyager 1 allows the spacecraft to analyze plasma vibrations at specified frequencies. The newly discovered signal is a low-frequency hum of around 3 kHz. And rather than being connected with occasional incidents, the signal was consistent across the 3 years, with minimal variation in its character. When we looked between and below these plasma oscillation events, we found this feeble, persistent signal of plasma waves that appears to not be related to solar activity, says Kogaku. The researchers can now access plasma density throughout the spacecraft's route, rather than just the isolated locations of the storms, thanks to the new signal's consistency. It was almost entirely unexpected to find this signal at points of space that, till a couple of decades ago, were completely unknown to mankind. Enjoyed the video so far? Then make sure to like this video and subscribe to the channel. Now, let's understand, why does this matter so much? The nature of the interstellar plasma is revealed by both the powerful intermittent signals and the weak continuous signals. The way the plasma's electric field swings, in particular, can be traced back to the density of the plasma. Researchers could only estimate plasma density during solar shock wave episodes previously. Researchers can calculate the density of the plasma all along the spacecraft's course from 2017 to 2020 using continuous data from the new signal. Furthermore, the researchers discovered that the new density measures are compatible with the previous ones, yielding the same results when taken simultaneously. The new findings enable researchers to transform a patchy record of plasma density with year-long gaps into a smooth, consistent form throughout space and time. The researchers discovered changes in density on 1 astronomical unit scale, the distance between the Earth and the Sun. Turbulence in the interstellar medium has long been thought to cause these changes. According to Kogaku, the exact nature of these changes recorded by researchers will help determine whether the turbulence is predominantly generated by massive, faraway sources such as supernova or more nearby sources such as solar wind. In addition to understanding the nature of interstellar turbulence, the researchers hope to learn more about the strange nature of the weak signal, which first appeared in 2017 and disappeared without explanation.